2 weeks ago, I watched the Social Dilemma movie documentary on
yes.
Netflix. So initially, I didn't want to watch it, but my parents were harassing me. It's like, you should watch it. It's good. So I didn't learn anything because I think for people that are programmer in this world, we know most of those things. But damn, that was demoralizing.
Well, why do you say it was demoralizing?
I don't know. It's like nothing was new, but like all the data mining and like the ads on people and like spying on them and things like, oh, I don't know. It was just demoralizing.
Yeah, well, I guess it's like when taken in aggregate, like the trend, the direction where we're heading to is not great, right? It's like not where we want to necessarily be going, but every individual like thing that's being done on its own is not as horribly bad as one might think. You know what I mean? I guess like the sum culminates into a direction that we don't want to go into.
Yeah. And all the thing about like the addiction, because I guess it's really addicting. So since then, on my Pixel, I enable the digital well-being focus mode all the time. So this means that I don't have any more notification for anything social, except when I click like, hey, I want to have notification. I feel like I'm looking way less at my cell phone now.
Yeah, I did the same actually. I didn't know that there was some setting, or I don't know if I have it, but I went through like every single app and whether it can deliver notifications or not.
Oh, okay.
And so only the ones that I want.
Okay, so for that's the thing, but with that it's like you decide when you get them. So normally I don't get any social one I flagged, but when I'm like, oh, I want to see what's fun, I can enable it for like 10 minutes.
Oh, that's cool.
Yeah.
No, I just miss all like everything that's happening on Facebook. It's completely gone. Like, I have no idea what's happening unless I like log in, right?
Welcome to Randomly Typed. I'm JS.
Hi, JS. I'm Lance.
So today we're not talking about Craigslist. We are talking about DNS.
DNS?
Oh, yes.
Domain name servers?
No, you're close. It's domain name system.
That's true. So I guess like DNSS is domain name system servers or server system.
Just before Christmas, Cloudflare just released a post about like new technology in DNS. So that's why I was thinking about that, and that's why I wrote this episode. And
nice. Cloudflare does all the things.
Honestly,
they're great. We're not sponsored by them, and we're impartial human beings. But I don't know. They're just cool. Everything they release is cool. If
they want to sponsor a podcast with 10 people listening to it, I'm really down.
Doesn't sound like a great business proposition.
It's niche, Lance.
But maybe if we just praise them more and more,
at some point
might happen one day.
Let's talk about DNS, the system in general, and at the end I'll talk about what they added to the standard and why I think it's pretty cool.
All right, I'm ready. This is going to be a networking class throwback.
Yes, I love networking, but hey.
I have a love-hate relationship with networking. There's so many nitty-gritties and like protocols and different layers of protocols and how they all work. And like Ethernet works by sending things and they conflict. So you have to like choose the random time frame. So it's always... Anyway, I digress. I'm ready. I'm pumped.
All right. So what's the goal of DNS, Lance? Tell me.
The goal of DNS is to not have to remember a bunch of numbers.
Okay, sure.
That is the goal.
We normally use it to translate like domain names like facebook.com to some IP, because on the internet you cannot address a server by name. You need to address it by IP. You get the IP from the DNS, and with that IP you communicate with the server. But DNS is more than that. Honestly, it's more of a key value store distributed over the internet, because you can store A records, which are the records with the IPs, but you can store so many other things for like configure your emails, random data. It's the only one I have in mind right now, but yeah, it's more than just IPs.
Yeah, if you want to connect a domain, so like a common strategy for what is it?
Let's encrypt.
Verifying that you own a domain is to set a text record with a random key that's given to you by thing, and then they can query.
Yeah.
They can query for it and then know that you put it there, presumably. Yeah, it's pretty cool. But yeah, so you're telling me that Google.com doesn't exist? It's not a real thing?
That's exactly what I'm saying, Lance.
Okay.
All right.
So it's just a bunch of numbers.
Just a bunch of number. So there's 4 types of DNS servers that are normally used on the internet. There's the recursive server, which is like the first one that your browser will normally hit. And it's called recursive because its job is to like look at the top, like .com, ask the .com DNS server, where is google.com? It gives you an address for those DNS servers. And for those DNS servers, you could ask where is like mail.google.com. So it's like hierarchy of like domains, and yeah, it's systems. So that
must get a lot of traffic.
Which one?
The recursive one.
Yeah.
And that like every browser has a list of. Oh well, wait, that's not true. You can like configure it at the network level,
exactly.
But it also has a list like as backups. I'm pretty sure.
So
your browser does.
Normally, what you get is when you connect to the internet to your ISP, your ISP tells you to use their recursive servers. So this means that pretty much every ISP on the planet have a bunch of servers. So this means that there's a lot of recursive servers on the internet.
Oh, it's a good thing we're doing this intro because, as you know, I have a love-hate relationship with networking.
We have a ton of recursive servers on the internet. So the ones we have the least amount of are the root name servers. So we have technically air quote 13 of them. So there's like 13 IPs hard-coded on the internet that we know are like the God name servers. They know where are the .com, .net, .org name servers. So they're controlled by organization and mostly around the US, but yeah, many companies and organizations in the US control like 1 servers or 2. So those are the root name servers. Afterward, you have the TLD name servers. So TLD is like .com, .ca.
Yeah.
So you have a bunch more of those. So you have, let's say 1, 2, or 3, or
however many TLDs there are.
Yeah. And for every TLD, you have a bunch of servers.
Yeah.
And those like tells you like where is like the domain lower. So like if you're in .com and you're looking for google.com, it will tell you, hey, here is the Google name server. And finally, you have the authoritative name server, which is the final one that knows and owns a domain, like the one that owns google.com. So it's the one that decides at the end what's the Google name servers. All the other ones are like just repeating what this one is saying. All right. So
all right.
That was a blast. So.
Oh my God. I feel like I hope there's not a pop quiz at the end.
Yeah, no, it's not at the end. It's right now.
Oh no.
Okay. So in this quick intro, did you spotted the 4 problems?
There are 4 problems? Okay, well, relating to what?
Okay, yeah. So like the next thing I want to talk about is like how DNS evolved to fix problems. What would be like the problems that the engineer designing DNS had to fix?
I'm so not ready, but let's do this.
Well, that's the question. Give me the 4 problems.
Can I have a hint?
Okay, sure. So, for example, at the beginning, the internet was like 3 scientists somewhere on the planet. Now it's like billions of people. What problems comes with that?
Is it? Please tell me.
Okay.
Because there are a lot of problems with that.
So
I don't know which one you're fishing for.
I'm fishing for the load. So initially, for the root name server thing, I said that there's 13 root name servers. So let's be honest, it's impossible that everyone on the planet is hitting 13 servers.
13 machines, yeah.
Exactly. All that was fixed is that Like the IPs are actually 13 IPs on the internet, but we use Anycast to talk to them. So Anycast is a way to distribute your servers. So you have like maybe 600 different servers that respond to the same IP. You have 13 IPs, but you have however many servers you want to respond to those queries. So that was the first way they fixed it, was to create Anycast.
That's a good way.
It's a good way.
So Anycast is like, I mean, you must specify where the servers are.
Yes. So normally, like it's IP is like 1 for 1, right? So, if you're going to this IP, it's one server. But how Anycast works is that like the steps in between you and that server knows that there's multiple servers for that IP. So it can decide how to load balance you between multiple servers. It's up to the internet infrastructure to know how to redirect.
I wonder how is that specified?
What do you mean?
Like, where do you specify, like, under this one IP?
Okay, but for example, let's say you have a switch somewhere in the ISP. Imagine that there's a config saying that this IP could go in this direction or in this direction.
Okay, cool. Okay.
So initially, Anycast was a hack on IPv4, but it's explicitly defined in IPv6, which was created 20 years ago?
Which no one uses yet.
Yep. Because for IPv4, it's up to the switches to lie, but in IPv6, it's actually defined.
It's an actual construct, I guess.
Yeah.
Okay, cool. Aren't we at 10% adoption?
Yeah, something like that.
Something like that.
Yeah.
Jeez. It's going to take a while, isn't it?
Yep. Well, honestly, I don't think we'll ever reach it. I think we'll just patch around it.
Yeah. There are too many old legacy systems and old hardware that doesn't understand that this is a thing.
Yeah, and just people not trying to go to IPv6.
Yeah, well, they're like, oh, well, this works.
Yeah,
so
exactly.
why would I change? Yeah.
All right, so that was the first problem, Lance. Do you have some random idea about some other problem you could see? Let's say you were designing DNS as Lance. What would you want to see different than
Okay, well, I have a few things.
Okay.
I don't know if they're the things, but so one of them is you have a bajillion machines across the planet that are supposed to represent a single key value that everyone can see, and making sure that replicates and propagates properly into a single consistent value is one problem.
Okay, that's actually interesting. Indeed, I was not trying to go there, but that's an interesting question because I didn't talk about it. But that was in the initial DNS design. Every value has a time to live. As we said earlier, the query goes through multiple servers, and a server can cache a result to go faster. But every value has a time to live. So let's say you're not allowed to cache it for more than 30 seconds. So this fixes the stale response problem.
And at least at some point.
Yes.
And it'll resolve.
And that if everyone works the right way, that after your time to live is done, you should never have stale data. If everyone played as they should.
Sure. I guess anyway, sure. It's still hard because some can catch some values that others didn't see and then cache those for long. Anyway, it's still a big mess.
But for example, because if you cache a value from another cache thing, I think you're supposed to do the difference in time. So you cannot have trend toward the infinity.
Yeah. But I guess your last change will eventually be the one that is reflected across the planet.
And eventually should be at worst the TTL.
Okay. So is security on the list?
Yes, that's
okay.
The rest is all about security.
That's the other one. Okay, so that's the other one I know is that DNS traffic is typically unencrypted, and so I was gonna say before DNS there's DNSSEC. That was a thing that nobody liked because it was really complicated.
Yes.
So it's really complicated, and you have to do a bunch of public key infrastructure stuff. And if you lose your keys, then goodbye. And nobody wanted to use it, and adoption was really low because it's complicated. That's my layman's understanding of the situation.
that was a solution, but the problem for that was was forging fake response or like impersonating a server.
Okay.
The other solutions we'll talk about afterward don't fix that problem. They're all different problems. Right now, the right way of preventing people of like faking results is DNSSEC. And yes, it's complicated, but I don't think it can be simpler.
No, probably not.
Super quick is like every DNS in the chain has like a public key, and you validate that every like DNS points to a DNS that was validated. So at the end, you just need the keys of like the 13 first root name servers. And if you follow the chain, you can validate that the data you got at the end is a valid one. It's like pretty much the same thing as certificates, like on the internet. But
so I was going to ask that next, is that like with things like, so this is analogous to like Let's Encrypt, where anyone is able to just get a certificate on their own.
Yes.
But I know Let's Encrypt, so certificates should solve this problem, but if you're just giving them to anyone, then they don't.
But the thing is to like enable DNSSEC on your, like, let's say your DNS server, you need to control the server.
Yeah.
So as long as you control the real server, anyone else on the planet cannot pretend that they're that server.
Right. Yeah, that's true.
The goal is like to prevent cache poisoning or like fake data. So there was created.
So bringing me back to Professor. I won't say the name, but their class is good stuff.
Yeah, the algorithm itself is kind of complicated, but that's the rough idea. So it was created in 2005, and it's still pretty much not used.
Yeah.
But honestly, at some point it will be, because like the new things that Cloudflare is trying to do relies on good data. So it relies on things being DNSSEC.
Oh. Huh.
Yeah.
Okay.
Right.
So is next like encrypted traffic?
Yes.
Is that okay?
Exactly. So the next problem is in-transit monitoring. So now we're not talking about impersonation. So no like active attack. It's just a passive attack. So let's say I'm on the same Wi-Fi as you. I just spy on the Wi-Fi and see all the domains you're reaching, right? So let's say you're going to supersecretive.com. Well, I know that you are a super secretive user.
Oh, a fellow user, I see.
And here, most of the time, the people are not thinking about their friends on the same Wi-Fi, but they're thinking about like they don't trust their ISP or like their governments, things like that.
Yeah.
We had DNS over TLS that was the RFC was created in 2016, and like really close afterward in 2018 there was DNS over HTTPS that was honestly pretty close, but right now DNS over HTTPS won. So both are pretty much the same thing. Is just you package your DNS query in an encrypted communication.
My layman's understanding of DOH, DNS over HTTPS, is that it works and it's simple, but people don't like it because it's less efficient than just sending like a DNS query. And one, it's like using the HTTP application protocol unnecessarily, and it's using TLS arguably unnecessarily, whereas ordinary DNS queries go over UDP and are theoretically like they manage their own protocol, right?
Mm-hmm. So yeah, normally your UDP packets will be faster than HTTPS because like HTTPS, you have all the like negotiation for like TLS and like retries and things like that. So normally it should be faster, but it's not dramatically slower.
I mean, also we use the internet like every day to go to everything, and it's good enough for most people, right? Like,
so, but there were some people that really hated that proposition because they were like, no, we cannot sniff on our users. So the Internet Service Provider Association from Britain, ISPA. So the ISPA nominated Mozilla as the Internet Villain Award for 2019.
Yes, I remember this.
Yeah, because they were preventing them from, air quote, filtering the internet as the government asked them.
Internet, I didn't know that there was like an Academy Award or something. Is there a red carpet? Does Mozilla have a very fancy dress?
Oh, that would be
that it
so
wears
funny.
And the winner for Internet Villain goes to
Mozilla. Woo! So the big difference between DNS over HTTPS and DNS over TLS is that HTTPS is like a protocol over TLS. So it's like more data, but it's more streamlined. It's harder to spot DNS over HTTPS on the internet than DNS over TLS because it's using the same port than normal HTTPS. So it's sneakier but slower.
And also like everything understands HTTP and like even just for like compatibility reasons, like people don't need to write another protocol implementation for the most part. Like it's
easy.
It should just work if you're able to make HTTPS requests and responses, like whether you're a client or a server. Yeah, I get that.
Yeah, I wrote a DNS over HTTPS client, and it was honestly just using curl and shoving some byte in it. Like it was a one-liner.
Yeah, you can't beat that. Yeah.
That was the third problem. Lance, what's the final security problem?
I can't think of anything, so you're gonna have to tell me, JS.
Okay, so here with DO or DOT, we were preventing passive observer from observing your traffic, right? But now, what if you don't trust your DNS provider?
So how is this different from the impersonation problem? Oh, okay. So it's not. Okay, so I guess the impersonation problem is more about making sure that the domain name you're requesting is controlled by the person that you're expecting to control that domain name. Yeah, okay. And this is different.
So DNSSEC is about receiving the right data. DO and DOT is about people in the middle can't know what's the data. And now ODO is about my DNS server provider cannot track my DNS queries. Because, for example, if my DO server, let's say Google, just tracks all my queries, they could just use it to sell me advertising or whatever,
Right. Odo, that's a fun name.
Yeah. And so it's oblivious DNS over HTTPS.
Cool.
Honestly, it's super simple. The idea is that they split the DNS resolving into two parts. The first one is like a proxy, and that proxies it to another DNS server. So for example, if I were an Odo client, I would go on DNS, request a DNSSEC, a key that's signed by DNSSEC for the server. So I get like a public key. I encrypt my DNS query with it. I send it to the resolver. So they receive a DNS query, but they don't have the private key. So they cannot decrypt it. The only thing they can do is send it to another DNS server that has the DNS key to decrypt it. So the second DNS server decrypts it, resolves it. So like go fetch the Google IP, re-encrypt it and send it back to the proxy, and the proxy send it to me. So this means that the proxy doesn't know the request and the actual DNS server doesn't know who requested that. So no one ever has all the info.
Oh, okay. Yeah, okay, that makes sense. I was gonna say that normally you would like encrypt when you have a chain like that, you would like encrypt the encrypted data. But I guess if you don't want any one person to know, then you need to have that like decrypt and re-encrypt phase in the middle.
Yeah, so it's really like Tor, pretty much what you're saying.
Yeah. I was gonna say it sounds similar.
Yeah, it's like Tor, but with like not multiple steps. It's just one step to hide the source that sends it to a server that can decrypt it. So here the weakness is that if the two DNS servers works together, they could rebuild the information. So that's the weakness.
Yeah, that's true. I guess there's no I guess you still need to trust that that won't happen.
Together. Yeah. So that's one weakness. And one other weakness, I might actually email them because I don't understand why they did it like that. It's like to get the DNS, to get the key you use to encrypt the query, you're requesting a DNS entry on the proxy. So this means that the proxy controls the public key, which in my opinion makes no sense because they could put anything there. Because they could put their own key that they control and have the private key.
Well, Could you say that again?
Okay. The proxy server
Yep.
has a DNS entry with a key that I use to encrypt the query. And normally, like when I send them the encrypted query, they send it to another server that has the decryption key. But the problem in my mind here is that since the proxy is the one putting the public key in their DNS.
Okay, yeah. It could also control up the private key for that public key and could just decrypt it on the proxy server. Yeah,
just on the fly and
Yep.
do some bamboozles or whatever. So I don't understand why we're getting the key from the proxy rather than the final endpoint. Because if we were getting it from the final endpoint, we would just have to trust the final endpoint.
Mm-hmm.
But here we need like to trust everyone on the chain.
Type up that email, JS. That makes sense to me as someone oblivious to all of this.
Yeah, I don't have an answer to that. I'll might Google or actually ask Cloudflare.
Yeah. Huh. Cool.
So yeah, that was my
all
Christmas
right.
break.
So those are the 4 problems.
Well,
nice.
That was the 4 problems I wanted to talk about.
Yeah, there are probably a lot more.
Yeah, probably.
But yeah, anytime DNS is mentioned on the internet, you get like a horde of angry forum users that are like, don't change my, I don't know. Yeah. Like, I feel like every new proposal I read, except I didn't read this latest one that you just explained, which is great. So, I mean, I don't know, but every, like, when DNS over HTTPS came out, there was so much flack given to it. They're like, putting an application level protocol inside another application level protocol. What is this? I remember so many people getting upset. Yeah. Oh, man.
But hey, in the end, I think it will win. But
yeah, well, path of least resistance.
That's the thing. Like, it's not perfect, but it's pretty good.
Yeah, but it'll do. Yeah.
Yeah.
Yeah, exactly.
So like earlier, I said that Cloudflare is pushing for DNSSEC because like they're also pushing for other new protocols. One is HPKE, if I remember correctly. Don't quote me on this acronym. But it's like
that's been a while. That's been around for a while.
Yeah,
I think.
Yeah. So the goal is to put like certificate keys in the DNS. So that's actually what is used in Odo, like to encrypt the thing. But they're planning to also use it to do zero handshake HTTPS. One of the things they're trying to do with HTTP 3 to accelerate it is to remove the handshake to enable the TLS connection. And one of the things is like putting the key in the DNS servers. Like there's way more into the actual thing, but that's like the global idea.
That's all. Are you going to link a bunch of these things in the show notes?
Yes.
I'm so down to read up about these.
Yes, there's I have all the links to everything.
Yes, beautiful, cool. Yeah, I gotta get back into this. Yeah, I used to be so involved in the like security / so involved. I used to be interested.
Lead hacker.
Yeah, no, very very much not. I think I'm not portraying myself very well there. Be interested and passionately consume these articles. But not these days. I've sort of fallen out of touch with it. So I'm down to start again. So thank you, Jess. This was really good.
But honestly, go read the Cloudflare blog. It's like it's good reading.
Yeah, well, I mean, I guess we're gonna praise Cloudflare once again, but they tend to release very thorough and very nice and good blog posts. So good on you, Cloudflare.
Yeah. For now, they're the good guys. But I'm kind of uncomfortable how
always
big they are.
Uneasy feeling, right? Yeah.
They're getting so big on the internet.
Yeah. Anytime Cloudflare goes down, it's like complete
madness,
chaos. Yeah.
I would argue that it's maybe worse than Google, but
yeah, maybe, probably, yeah. So keep being good, please.
Don't be evil.
Yeah.
Anyway, well, that's all I got.
Thank you so much. This was really, really good.
Thanks, Lance.
I hope you listeners enjoyed it as much as I did.
See you in some days.
Whenever we find time.
You have something to say.
Things to talk about. Yeah.
All right. Thanks.
Cool. Which will be soon. I don't doubt it.
Oh.
Alrighty. Relatively soon. You know, like in the relative sense, like probably at least within like an order of magnitude of the previous frequency is my guess. Like at least, right?
So not 10 times worse, right?
Like, let's try to keep the standard deviation of the interval at which we release things to be pretty low. Like, let's try to be as consistent, okay. But also whatever. Right. Okie dokie. Thanks, Jess.
Thanks.
See you later.
This podcast is both free and free, as it's distributed under the Creative Commons.
You can contact us and find show notes on our website, randomlytyped.com.
The intro music is by Vansky.
Thank you, Vansky.
And thank you, listener, for indulging us.